Hello everyone, we welcome you to this new amazing video by PM Company. PM Company in collaboration with LNM IIT has developed an instrumental cluster over Qt that is specifically designed for Indian car manufacturers OEMs. First of all, let us understand what is an instrumental cluster. A car's instrumental cluster houses the various displays and indicators that enables the driver to operate the vehicle. Among these are several gauges, often a speedometer, an odometer, a tachometer, an oil pressure gauge, a fuel gauge, etc., as well as various indicators for system malfunctions and warnings. Before moving ahead, we would like to thank our constant support and project mentor Dr. Abhishek Sharma and the two online sites that shall be visible to you now. The first one in the list is the YouTube channel by Qt itself, and second one is the GitHub link. For your reference, we shall also be sharing the links to these sites. Now, without wasting any time, we shall straightforward move to the software simulation. For software simulation, we have used Qt Design Studio, which consists of the QML text editor and the form editor. We shall be using both of these simultaneously to get our desired output. Our software consists of a tachometer, a speedometer, a fuel gauge, some gear shift indicators, and light indicators as warnings. It's difficult to understand all of these in one go, so let's take only one of these. For your reference, we are taking the fuel gauge as the first step to understand these meters and gauges. Beginning with the fuel gauge. In the first view, the fuel gauge seems to be a single unit consisting of a meter, a needle, colored notations. But actually, it is a combination of various units consisting of a needle as a unit, this meter as another unit, and all these readings as another unit. Built over Photoshop, and these are combined in Qt. Let's begin with how this needle actually moves to give us the actual reading. In the timeline, we can see that as time moves ahead, this needle moves ahead too and goes below. So this indicates fuel high and fuel low values. But how is this needle rotating? We have not done anything in Photoshop, so let's understand. So we have actually connected this needle to a square surface here. If we go to the navigation menu, we can see that our fuel needle is hierarchical to item 1. Item 1 is this square box that is rotating actually, not the needle. So as and when this box rotates, our needle is also rotating. As we can see clearly in the timeline, as we move ahead, our needle rotates. Let us try to understand each property of this fuel gauge one by one. First one is item 1 that we have already understood, that was the square box that was rotating the needle. Second one is the arc. So when we move ahead, our arc is moving. The arc is this part. As we can see in the mouse cursor, the arc will increase in time and decreases again. So this is moving with the needle. The arc is representing the needle value. It is actually highlighting the needle, we can say. Having been understood this much, let us try to simulate this once again. Have a look at this fuel gauge. Also look at the values. We shall be considering all these things after some time, but you need to have a look at this once. Did you find any error in these? So the error is that we have tried to keep the color of these values highlighting as and when the value of this arc changes, as the color of this arc changes. But somewhere or the other, like in the values 35, 30, 25, 20, the colors of this is not in coordination with the color of this arc, as we can see clearly. Since this glows to yellow, this is still green. This is not actually a mistake from our end. We have deliberately left it like this so that we can make you understand it better. Let's go back to the timeline and the text edit. Here we see that as and when we go to value 35, the color should have been changed to yellow. Or if we move ahead to further 25 and values like these, the color should be red in 25, but it is still green. Now we'll teach you how to change these so that you get a glimpse of what had actually happened. So if we click on value 25, the stroke value in the item should have changed the value. So at 25, we want the color of this to be highlighted as red, as we have seen in say 15 or maybe 20. So we want the same color as 20. So first of all, let us select the color of 20. So it was somewhat yellow color. So we can copy this color, Control C, okay. And now, and when we go to 25, we want to record what we have actually changed. So we put on the recording, we go 25, this was item 195.36. This we can go by clicking on this, the item that is actually 25, it gets highlighted, and the color which is green now, we need to change it to a color same as 20. So actually, so I'll change the color, okay. And when I now try to play this, I expect that I get a yellow color. So what has actually happened, the color should have changed to yellow. So let us now see, did we get our desired result or not. So to do this, we need to simulate the result. Let us simulate it. So simulate, save all our changes. Now the color at 25 should have become yellow. So it is somewhere yellow and somewhere green. So maybe there is an error. Let's see what was it. So for this, like uh, as we can see that it is somewhere getting yellow and somewhere getting green. So we need to add a point here. So here we go on our text and we see that we need to insert a keyframe here and a keyframe at this end. So a keyframe means that we need to set this value for permanent. So we are setting the keyframes at these values to be yellow color. And for green colors, I need to set these as yellow again. I hope we must now have reached our desired result. To check that, we need to simulate it again. So on simulating, we need to check the value of 25, the highlighting color of 25. So on getting the value at 25, the color should have changed to yellow that was initially green. Let's check. So yeah, finally we have changed this color to yellow. And further, like this only, we can change all the other color values. Next, we can check that at 15, the value does not glow up like all others. At 45, it highlights up. At 40, it highlights up. At 35, it highlights up. But this thing does not happen at 15. Let's check. I hope you have got what I was talking about. So let's do this also. To check that, let's go to the value 15. This is 15. And on moving with 15, let's check it is item 195.34. So on moving ahead after 15, this is actually not glowing up. Let us check what the error is actually. So let's check for 10 first. On moving with 10, you can check the value of scale actually changes. For 10, let us check what the value of 10 is. So it is 195.33. So on checking for 10, 195 underscore 33 moves the scale value as, moving with 10 moves as, see, it changes to 1.2 and then it is back again 1.414 and 1.00. So same should have happened for 115th value also. So but it is actually a constant at 1. So we need to change these values. So on moving one step further, this should have changed to 1.14. And again on moving other step, it should have changed to 1.20. And the last, it should have changed to 1.14. Now, you should have taken care of that. The recording button should have been on. In my case, it's already on, so I have not toggled it, but it should be on to change if you are changing any value in this. So let's move it again. Simulate. Save all the changes that we have made. And let's check what happens to the value of 15 now. See, the value of 15 actually toggled, but not that much, so there's an error. So with hit and try, we can change the value. So if I use hit and try value method here also, So with hit and try method, the 15th value was not actually toggling very well. So see, this has actually changed the value. So I need to add a breakpoint here for 1.00, and it is actually increasing in a flow. Not it is a random increase like it was in others, like from 1.00 to 1.1 and 1.2. So this is actually not an issue. So if we play it, this goes well. So I hope you understand how we got a glimpse of what is actually happening using the image editor. Now next, let us check one more thing. With the changing value, the value of this liters is not very much matching to the analog meter. The digital meter is not very much matching to the analog meter. As you can check at 25, it was 27 or something around that. At 15, it is very much higher, 18. So this is an error because there is a file called simulation.js in the backend. We go to data and we get the value simulation.js. So when we move here, we need to check where were the reading for fuel gauge. So for fuel gauge, we have this is the function liters timer. Now because of some of this is the formula that we have used here, and this is not very much accurate to what we were to use. So since we have rounded it off, this is somewhat closer to the actual value but not very much matching to the actual value. So there is somewhat an error in it, but that's not much of an issue. So if we change the value and get the exact formula, we can actually match the analog meter and the digital meter too. So finally, once again, I'll be playing the simulation for you so that you understand what we have actually done. So this is a logo that we have made and we have rotated it in the beginning. This is the gear shifters that moves with increase in speed. So at 40 or 45 this moves to second gear, and simultaneously further with increase in speed the gears shift also. Now when this RPM meter is above value 8, the engine light gets on. This shows the engine is heating up too fast, and when the fuel meter is less than 15 liters, then the fuel light also gets on to show that fuel level is low and we need to fill it up again. So this was the project by Prakhar and Mohit with in collaboration with LNM IIT. For any queries and suggestions, you are highly welcome. Thanks and have a nice day.